Hello everybody, welcome to at NEET Physics by Arun video channel. In today's video, we are going to solve a problem in heat and thermodynamics. Very simple problem. The question is, a container has two chambers of volumes V1 is equal to 2 liters and V2 is equal to 3 liters, separated by a partition made of a thermal insulator. The chambers contain N1 is equal to 5 and N2 is equal to 4 moles of ideal gas. At pressure P1 is equal to 1 atmosphere, 1 atm, and P2 is equal to 2 atm respectively. When the partition is removed, the mixture attains an equilibrium pressure of how much? Equilibrium pressure of number 1, 1.3 atm, 1.6 atm, 1.4 atm, and the last one is 1.8 atm. Either item. So we have two chambers. For the first chamber, V1 is the volume, 1 atm is the pressure, and 5 is the number of moles of ideal gases. For the second chamber, V2 is the volume, 3 liters, and P2 is the pressure, 2 atm, and N2 is equal to 4 moles is the of gas, quantity of gas inside the chamber. What happens is, we are removing the partition. So after removing the partition, the gases will be moving here and there. Finally, they will attain an equilibrium pressure, and the amount of pressure that exists after the removal of the partition is what you are going to find out, what you are going to calculate. So you know that P1 V1 is equal to P2 V1 plus P2 V2 is equal to. So what is this? For chamber 1, pressure P1, volume P1. For chamber 2, pressure P2, volume P2. So this is when the partition is removed, it will attain a final pressure, and also total volume occupied by the gas will be 2 plus 3, 5. So V1 plus V2. So this is the equation. So here, as we have a thermal insulator is placed between them, there is no temperature difference between them. There is no such things has been given in the question. Okay, that's all. So P1 pressure of the gas in chamber 1, 1 atm. P2 pressure of the gas in chamber 2, chamber 2, 2 atm. 2 atmospheric pressure, 1 atmospheric pressure. Okay. So we have to write the volumes also, and finally we will calculate the pressure. So V1 volume of chamber 1, 2 liters, V2 volume of chamber 2, 3 liters. So P is the equilibrium pressure of the gas. This means substituting the values in equation. 1 into V1, V1 1 atmosphere, V1 2 liters, 1 into 2, plus V2 V2 2 atmosphere, 3 liters. Is equal to P, final equilibrium pressure, final equilibrium pressure, plus P1 plus V2, 2 plus 3. Very simple. 4 and 2, so 2 plus 6, 8. Is equal to P into 2 plus 3. So P is equal to 8 divided by 3. 4 and 5, meaning 30, 30. So 1.6 atm, 1.6 atmospheric pressure is the equilibrium pressure attained by the gas after the removal of the partition. Okay, so option 2 is the right answer. Option 2 is the right answer. You will see one more question in this chapter, heat and thermodynamics, in our next video. Till then, thank you one and all.